start this unit with a review of some exponents. An exponent is a number or variable that tells us how many times to multiply the base by itself. So in this equation of y equals a to the x, we've got a is the base and x is the exponent. The exponent tells us how many times the base is multiplied by itself. So in the case of 3 to the 5th, it tells us we're going to take the 3 and multiply it by itself 5 times. Or in the case of x to the 5th, we're going to take x and multiply it by itself 5 times. There are some key rules you need to remember, or the laws of exponents when you're working with exponents. The first one says that when you've got a to the exponent m times a to the exponent n, since the bases are the same, they're both a, you can simply add the two exponents together to get the product of those two. As an example, if we had 3 squared times 3 to the 5th, it would be equal to 3 to the 7th. The quotient, or when we're dividing, if we've got a to the m divided by a to the exponent n, we simply then subtract the exponents. So if we had 3 to the 5th divided by 3 to the 2nd, we would end up with 3 to the 3rd. In the case of an exponent on an exponent, here we've got the base a to the exponent m, all of that raised to the exponent n. In that circumstance, we multiply the two exponents together. Continuing with our example, if we had 3 to the 5th raised to the 2nd power, that would be 3 to the 10th. If we have a negative exponent, that tells us to put 1 over whatever the value is. So if we've got 3 to the negative 5, that's actually 1 over 3 to the 5th. A fractional exponent is the way of conveying roots. So a to the exponent 1/3 is actually telling us to find the cube root of that value. So the number 9 to the exponent 1/3 is actually telling us to find the cube root of 9. If we have an exponent on a product where two numbers are being multiplied together, it's the same as if those two variables, a and b in this case, had the same exponent on them. So 3 times 2 squared would be the same as 3 squared times 2 squared. If we have a power on a fraction, so we've got the exponent m on the fraction a over b, the exponent can be assumed to be on both a and b in the fraction. So 3 over 2 raised to the 5th power would be the same as 3 to the 5th power over 2 to the 5th power. Try the practice questions. In these questions, if you're trying to solve for the base, the exponent becomes the root on the other side of the equation. Let's see how that works. With the first one, we've got x cubed is equal to 343. Therefore, x is equal to the cube root of 343, which we can do on our calculator, and we find that it's equal to 7. Similarly, with x to the 7th, we can say that x is equal to the 7th root of 279,936. And again, doing it on our calculator, we get x equal to 6. If you're trying to solve for an exponent, you rewrite both sides using the same base and then compare exponents. We will actually get a better way to do this a little bit later on in the unit using logarithms, but for now, this is the approach that we're going to use. 2 to the x is equal to 2 cubed. Therefore, we can conclude that x is equal to 3. So what we did is we looked at the 8 and we asked what number cubed makes 8. And we know that 2 cubed makes 8, so we could come to the conclusion then that x is equal to 3. In the case of 729 to the exponent x is equal to 3, it's not quite as obvious what the solution is going to be, but we're going to follow a similar approach. For the moment, we're going to assume that 729 is going to be a factor of 3. So I'm looking for the exponent to put on 3 that will give me 729. So 3 to what exponent will give me 729? And that's raised to the exponent x. With a little bit of experimentation, I can find that 3 to the exponent 6 gives me 729 to the exponent x equals 3. Now remember, when we have an exponent on an exponent, as we do here, we can simply multiply those together. So we've got 3 to the exponent 6x is equal to 3, and the exponent on the 3 is 1. Therefore, we conclude that 6x is equal to 1, and x is therefore equal to 1/6.